Here's the review for chapter 5. You know what? I'm going to skip to number 3 because number 3 is actually a good warm-up for many of these. So, write an equation of a line that passes through the point 2, -3, so that's your x, and -3 is your y, and it has a slope of -4. Now that's your m. So, the way the vast majority of us are doing this is using point-slope form, so I'll start with that. I'll show you a second way though too if you realize that point slope form wasn't going well for me. I want to try this other thing. So we substitute our y in after the first y. So it actually becomes y minus -3, which is equivalent to y plus 3. And then we substitute our x in after our second x, or in for our second x. Next step is to distribute the -4, so we get -4x plus 8. And then last step, get this into slope-intercept form, so solve for y. So we get y equals -4x plus 5. If you're cool with that, skip ahead to example 1 here in a second. But here's your other option, or your alternative, if you don't like point-slope form. Use slope-intercept form. Why don't we just do that the first time? Well, it takes like 2 steps, or 2 substitution steps that a lot of people forget the second substitution. So it is still plugging in -3 for y, plugging in -4 for slope, plugging 2 in for x. Make sure you take m times x here. And we don't know what the y-intercept is. Otherwise we would have just plugged both the slope in for m and the y-intercept in for b and we'd be done. But we don't know the y-intercept. So simplify the right side. You get -8. Solve for b. Solve for the y-intercept. Find the y-intercept. Calculate the y-intercept if we know the slope and a point it goes through. So we get b equals 5. I'm going to circle that, but that's not the answer, folks. I know that the slope is 4 and I know the y-intercept is 5. So substitute in -4 for m in slope-intercept form. Plug in 5 for b. Notice our answers match. Bada bing, bada boom. Number 1 says write the equation of a line that's parallel. Parallel lines have the same slope, or equal slopes. Write the equation of a line that's parallel to this one and goes through this point. So this first line has a slope of 4/5. So the slope of our line that goes through this point is also going to have a slope of 4/5. So we can use our point slope form here. That's a 4. Distribute. You know, 4/5 times 0 is really nothing. So it's 0. I don't need to write down -0 or +0 or anything. And then we just solve for y by adding 1. So that now this 4/5 x and this +1 or this 1 are not like terms, so we can't combine them. So we just get 4/5 x plus 1. Again, you could do it this way, plugging things into slope-intercept form. X is 0, and we don't know the y-intercept, so we're solving it. 4 times 0 is 0, divided by 5 is still 0. So really we have 0 plus b equals 1, so b equals 1. So go back and plug it into slope-intercept form. So y equals, your slope is 4/5, your y-intercept is 1. All right. What is the slope of the line perpendicular to this line? Well, the slope of this line is 2. So the slope of my perpendicular line is -1/2. Opposite reciprocal. Perpendicular lines have opposite. That means if one's positive, one's negative. Reciprocal slopes. Reciprocal. So you take the absolute value of the two numbers, the rise and the run. And by the way, this 2 is the same as 2 over 1. Take the 2 and the 1. Ignore if there was a negative at the moment. And just, the reciprocal means to switch the top and the bottom number, numerator and the denominator. So the 1 and the 2 flip. Then, that's the reciprocal, then take the opposites. This is a positive fraction, or a positive slope, so this needs to be a negative slope. So the slope of the line that goes through for negative 3 has to have a slope of negative 1/2. So you can use your point slope form. Y plus 3 equals negative 1/2 x minus 4. Distribute, so you get negative 1/2 x. Check this out at negative 1/2, or what's half of 4? Half of 4 is 2. Then think we had a negative times a negative, that's a positive. Last step, subtract 3. So you get y equals negative 1/2 x minus 1. Or you can use slope-intercept form. So plug negative 3 in for y, plug negative 1/2 in for m, plug 4 in for x. We don't know the y-intercept, so simplify the right side, you get negative 2. Now solve for the y-intercept by adding 2. You get that the y-intercept is negative 1. When you go back and plug in your slope and your y-intercept, you get that. Isn't that beautiful? Write the following equation, y equals 3x minus 4, in standard form. Standard form looks like this, where a, b, and c must be integers. No fractions, no decimals, and the caveat is that a must be positive. So what I'm working with here is y equals 3x minus 4. So your answer will have an x term and a y term on the left, and then a plain old number on the right. A, B, and C just represent numbers. So the issue is, well, it's good that I have y on the left of the equal sign. I should have that. But the issue is that I have x on the right side of the equal sign. So I want to undo this x by subtracting 3x. That gets it away from the right side, or out of the right side. But what I do to one side, I have to do on the left. So we can't combine these. So we get negative 3x plus y. The 3x is negative, the y is positive, and on the right side I'm left with negative 4. Now that's cool, except for we're supposed to have our leading coefficient be positive here. So we're going to multiply everything by negative 1. We're going to distribute negative 1 to every term, even the term on the other side of the equal sign. This essentially makes everything the opposite. So this negative 3x becomes a positive 3x, this positive y becomes a negative y, the negative 4 becomes a positive 4. That is in standard form. I realize I'm going fast, so if you need to pause or rewind or listen to, do that. Number 5 says write the equation of a line with a slope of 7 and a y-intercept of 12,135. So this slope is your m. The slope is m, and the y-intercept is that huge number. So we just simply substitute these in, because now I actually have the slope and the y-intercept. So this is really easy. Y equals 7x plus 12,135. Done. Number 6, write the equation of a vertical line that goes through the point 7, negative 2. So there we go. What is that going to look like? Make a little sketch, folks. 7, negative 2 is right 7, down 2. It's a vertical line, so that means it's going straight up and down. You could plot some points along here and make a little table to figure out a rule. An equation is just a rule for that line. So the rule is, well, if I write down some coordinate pairs, you know what? No matter what, x is always 7. X is 7. That's the rule. It doesn't matter what y is. Y can be a positive million or a negative million, but my x is 7. So that means x equals 7. That's the rule. Any location on this line, the x value is 7. I'm going to skip down to number 8 now. Write an equation of a horizontal line going through the point 4, 5. So let's plot the point 4, 5. Boom. It's got to be a horizontal line this time. So let's put some points on there. Let's make a little table to try to find a pattern. So we've got 0, 5. Always put x on the left and y on the right. That's really the way your coordinate pairs work. X is 0, y is 5. X is 2, y is 5. X is 4, y is 5. The rule is that y is always 5, no matter how far to the left, no matter how negative x gets, or how far to the right, how positive and large y gets. So y equals 5. Boom. Number 7, write the equation of the line below. Well, if we can identify the y-intercept and we can identify the slope, then we can quickly put it into slope-intercept form. The y-intercept is 2. So b equals 2. But we need to know the slope, which is also the rise divided by the run. M equals rise over run. So we're going to make our rise-run triangle. I know the points or the location right there. I shouldn't probably do that so darkly. It's positive 2. And then I know, let's see, I clearly can identify the coordinates right there. That's 3, 0. And that again was 0, 2. So make your rise-run triangle. Make a straight vertical line that shows the height from these 2 points, or the height between these 2 points, or the rise, and then make a horizontal line that shows the run, or the horizontal change between these 2 points. So the rise length is 2, the run length is 3. 0 to 3 is 3, 0 up to 2 is 2, but that has to go rise over run, so that's 2/3. Now careful here. It's got to be a 2, because that's the rise, and on top of the run, which is 3. However, notice that as we move from left to right, we're actually dropping. This red line is a negatively sloped line, and our slope needs to be a negative value. So put a negative up top or out in front. So y equals negative 2/3. Take that slope, multiply it by x, and then add your y-intercept, which is 2. Boom. There we go.